Now, let's finish with the normal distribution. And I'm going to use the whole video, this video, only for the normal distribution because it has a little bit more complex and is extremely important. Normal distribution. And we are going to use this normal distribution from now on for the rest of the semester and for, of course, the rest of the quantitative management as well. Okay. Normal distribution. Okay, normal distribution is what is called a bell-shaped distribution. It's like a bell shape. Okay? This distribution has the mean that is mu and have a standard deviation that is equal to sigma. Okay? The characteristic of the normal distribution is that it's a symmetrical distribution. It means that if we fold it, it is exactly the same this way and this way. Okay? So we know that this area over here has to be equal to 0.5, and the whole, because of the whole area is equal to 1. So half of it is 0.5 and the other half is 0.5. One important normal distribution is what is called the standard normal distribution. The standard normal distribution is a normal distribution that has the mean equal to 0 and sigma is equal to 1. That is an extremely important distribution. What else? And why is it so important? Because we have tables, and the tables are in the first part of your book is the normal distribution, the standard normal distribution probability tables. And let's do a few problems with normal distribution, so you know how to read these tables. Okay, one important thing is that when we talk about the standard normal distribution, we say that instead of this an x, this is a z, and z. A z is always the standard normal distribution. And okay, let's say that we have problem 12E. They said that given that z is a standard normal random variable, compute the probability of z is less than 1.2. Okay. In order to do that, we have to go to the tables, okay? And if you see the tables, okay, remember, the mean is 0, so it means that these numbers over here are negative, and these numbers are over here are positive. So since we are dealing with a positive side, we are dealing with the right side of the table, and we are going to look for z equal to 1.2. 1.2 is about this one, and the probability then is 0.8849. Okay? Because the table gives the areas on the left side of the z. Now, let's say that I have, what is the probability that z is less than 1, less or equal is exactly the same than less, 1.24, okay? So I'm going to go back to my book, and I'm going to find 1.2. I'm not going going to, there is no 1.24 in this column, but over here on the top row of the table, you're going to find 0.00, 0.01, 0.02, and so on until 0.09. This is the second decimal point, and the second decimal point is 0.04. So you're going to look in the 0.04 column, and then the probability of 1.24 is 0.8925. The probability that Z, the standard normal distribution, is less than 1.25 is, this is the probability. So we have in order to read the tables, we have three possibilities. Whether we are looking to the left of 1 point, or we are looking to the right. Okay, what am I going to do in this case? For this case, I go directly to the table and look the value of my A, and that is the probability. What happened here? I know that the whole thing is equal to 1, and I'm looking for this part. So it has to be 1 minus what is in the table for A. Now, it doesn't matter where A is located. A can be in the positive side or in the negative side, and the same thing here. The positive side and the negative side. It really doesn't matter. The question is, when I have this situation that is asking me the probability that the Z value is between an interval, what I need to do is to get the higher number and put it in the table, or get it from the table, minus what is in the table from A. Okay, from the lowest number is what is in the table for B, that is going to give us all this area, but since we are interested in only this one, we have to delete this area over here. So that is why. So that's it. There is no other way that they can ask you probabilities. Either it's in the left side or in the right side or between an interval. If it's in the left side, go directly to the table and get the probability. If it's in the right side that you're looking for, go to the table, get the number, and then say 1 minus the number that is in the table. That is the probability in the table. And if you are dealing with an interval, go to the table, get the probability from B, the highest number, minus the probability of the lowest number, that is A, and you subtract those elements and you get the probabilities. Like in any other probability distribution, the probability that X is equal to a particular number is equal to 0 because there are no areas involved. Now, what else? Let's say that we already covered that one. Okay, now, why is the standard normal distribution so important? Well, it is so important because we have the tables that tell us the probabilities. Now, I have this standard normal distribution with mean equal to 0 and sigma equal to 1. However, in reality, in the real life, we are not going to find any situation where we have a standard normal distribution with the mean equal to 0 and the standard deviation equal to 1. The majority of the time, we are going to find distributions, normal distributions, with mean equal to mu and sigma equal to sigma, whatever number it is. So we want to find a way. This is X, this is Z. We need to find a way to transform any normal distribution into a standard normal distribution in order to what? In order to calculate probabilities. And the way to do that is through the formula C is equal to X minus mu divided by sigma. So we are going to transfer to the Z probability distribution, to the standard normal distribution, whatever value is in here. And let's do one. And guys, this is the only formula that I require you to memorize. Z is equal to X minus mu divided by sigma. Okay. Okay, let's do problem number 22. It says, the mean hourly pay rate for financial manager in the East North Central region is 32.62. Okay, since we are dealing with normal distribution, I am assuming that this is a normal distribution. Oh no, it is normally distributed. So they tell you that mu is equal to 32.62. That's what it is. This is the mean of the distribution. This is the mean hourly pay rate of the financial managers. And the standard distribution is 2.32. Okay? So they are giving us from the standard normal distribution, this is 32.62, and the sigma is equal to 2.32. What is the probability a financial manager earns between 30 and 35? Between 30 and 35. This is 30, this is 35. Because the mean is 32, so 30 has to be in the left side and 35 in the right side. Okay? Now, how are we going to approach this? I mean, there are no tables for the normal distribution with mu is equal to 32.62 and sigma 2.32. Now, this normal distribution can be translated into a standard normal distribution using this formula. C is equal to X minus mu divided by sigma. So, what is my 30? So, I'm going to translate this into the C with mean equal to 0. Okay, what is this 30 over here? Okay, that's the C that I'm going to take. Is X. What is X? 30. That's the value of the 30 that I'm looking for in these X's. Minus mu. What is mu? Minus 32.62 divided by sigma 2.32. And that is equal to 30 minus 32.62 divided by 2.32. This is a negative 1.13. This is negative 1.13. Now, what is this one over here? That is 35. I'm going to do exactly the same. C is equal to 35 minus 32.62 divided by 2.32. And that is 35 minus 62 divided by 2.32. 1.03. This is 1.03. Okay? And this area is exactly this area over here. So if I found out what is this area is exactly this one because I translate